we have Professor Faith Osier, whom we heard earlier today. So you're Professor of Malaria Immunology, and your research focuses on acquisition of natural immunity of malaria, and you mainly work in Heidelberg University Hospital in Germany, but also at the Kemri Wellcome Trust Research Program in Kenya. And also we have a surprise visitor joining us here, that Professor Christian Drosten, who is based here in Berlin. He's director of the Institute of Virology at Charité Berlin. And so we're going to pause for a second. Okay, is that okay? Good, perfect. So let's first of all start with a follow-up to your really tantalizing presentation earlier, and that is, since you have shown that there is that innate immunity to malaria, how come we don't have a vaccine yet, and how long will it take before we can have one?
Well, our problem really is that we've known that people can become immune for many years. But for a long time, we didn't know just how complex the parasite was. And it was about 2002, 2004 that we had the whole genome of the parasite. And so once we had that, then the magnitude of the problem became clear, that this parasite has over 5,000 proteins that it expresses. And so when you're looking for the antibody that can do the magic of immunity, you are looking for a needle in a haystack, because there are just so many proteins. And the proteins change in different parts of the body. And then the genes are polymorphic. You know, if you sample different people and you look at the same locus, you find that there are variations in the gene. So it's even surprising that people acquire immunity even though the parasite is constantly evolving. And so first we start with a big pool of proteins to say, okay, which one? And then within those proteins, the parasite is subtly changing over time. And that's the complexity. That's why it's taking a long time. And that's why no one can really give you the answer like when, because we are looking for it. Yes.
Exactly.
Yes.
So, Christian, you work not on malaria directly, but of course on other pathogens, viral pathogens. And you spent quite a lot of time thinking about evolution. So we just heard from Faith about that dynamic, the rapid changes, evolutionary changes. How can we track that, and how different is that in different pathogens?
Well, so those pathogens are all very different, first of all. Then to track evolution, I would say many people think this is solved. We can track evolution backwards in time. The big challenge, of course, is to predict, right? Especially in infectious diseases, this claim to predict evolution is all around. I guess one of the fields where this is most advanced is the prediction of the, let's say, antigenic variability in influenza virus, right? Where we have a pressure to select the right vaccine candidate each year, basically. And there are groups of evolutionary biologists who model not only backwards in time how the genome of the virus evolves, but they look for predictions regarding the interaction of the surface proteins of this virus with the broader immune system of humans. So let's say with all the antibodies that humans raise against this virus, there are some advances there. So we have some successes. I think the selection of candidate strains is improving, but this is predicting, let's say, 1 year from now, maximum. And, these predictions still are not right every time. So this is about the most advanced field in evolutionary biology of pathogens where these predictions can be made.
Mm-hmm. So you, obviously, a pathogen exists in an environment of a host. And you talked about adults who live in malarial areas who develop that immunity, and then you contrasted that, for example, if I was to go on a holiday, and of course I would not have that immunity. But is there something more specific about genetics of the host, or if I went to live in Kenya for most of my life, what would be my chances of developing that immunity?
So it correlates really well with how much malaria you actually experience. If you come on holiday once a year, every 5 years, you won't have any immunity. I've grown up in Kenya. I'm not immune to malaria. And the people that get immune really are having infections repeatedly, maybe 10, maybe 20 times a year, every year. That's the amount that you need to get, that then you build solid immunity. So not short trips, but I think it is possible for anybody to acquire it. It's about the amount of exposure that you receive. And we could see it from the neurosyphilis studies a long time ago, where they used to try and treat people with syphilis, with a malarial fever, and you would be infected with one strain. But after some time, they had to change the strain that they infected you with, because the first one, you were already becoming used to it. So I think it really is possible, and it's a matter of how frequent and intense is the exposure. Yes.
And what about, you showed these tantalizing graphs of some individuals in your trial when you were infecting them who didn't actually, in their system, the parasites didn't grow at all. Whereas others, there would be a build-up of parasite, but then they would obviously... what's the difference between these individuals? Did you look at that?
Yes, so that's something that's still fascinating to us, because from the graphs I showed you, based on the way the parasite is growing, we can see 3 types of individuals. When we look immunologically through all our measurements of antibody and mechanisms of function, this is indistinct. We cannot separate those 3 types of individuals. And so it looks like some sort of continuum. But that's really fascinating. At the moment, immunologically, they look the same.
Wow,
yes.
That's really amazing. And Christian, in the other infections or infection agents that you study, is there also that separation in populations, how they react at this immunological level? Are there similarities?
Well, there are always these differentiations of immune reactions. Of course, there are some explanations here and there, right? But it's very difficult to... Well, I mean, prior exposure is one example, but then, of course, there is the whole field of cellular immunity. And, of course, there is differentiation of different HLA types, like in white cell surface markers, that correlate with the propensity to develop immunity, especially against more complex organisms such as parasites, bacteria. So there are multiple examples in the textbooks, but malaria is a particularly difficult case.
Yes. So I can't help but ask this question. We're talking about potentially this hope that there may be a vaccination against malaria based on the findings you described. Can we imagine a time where we would actually eradicate malaria, like we no longer have polio, for example? Is that possible? Could we see that in our lifetime?
I personally hold that as a vision, because I believe you need to see where you're going and you need to feel what it will be like. And I think the fact that we've eradicated polio says to me that we can. And so I'm an optimist, and this is a divisive topic, but I'm on the side that says we can do this, and we've got so much technology now, and it seems to me that we're gonna crack it. It's just a matter of time. And when I think that people are going to the moon on holiday, there's so much that we can do. And now we understand the parasite, we understand the problem, we've got the tools. I'm optimistic that we can do it in our lifetime.
What would you say? What do you think?
Well, so malaria, I guess, has some of the prerequisites that a pathogen should bring for it to be a realistic eradication target, right? So one of these prerequisites is we know it is specific for humans. So there is not a vast array of animals in nature that also will amplify or spread the same pathogen, right? Then there is a very clear way of transmission that can be interrupted. So this is a good precondition. But then this parasite is complex and difficult to target, right? So it's not that simple drug that you give or that simple vaccination, even though you're very optimistic there. It is really complex. So the interventions are difficult, the preconditions are favorable, I would say.
That's interesting. So you mentioned breaking the transmission, and of course there have been many attempts trying to control the mosquito as a vector. Do you think that maybe we should be looking at a multi-pronged approach? I mean, it is true that many of the attempts to control the mosquitoes have not been very successful, actually. Do you have any other specific reasons, or are we not doing it systematically enough, or maybe we're trying things one at a time? Why do you think that is, that we haven't been so successful in that?
So my view is that we've got to try absolutely everything. And if it was something easy to solve, we'd have already done it. You know, so I'm not critical of any approach, because we've got a huge problem, a massive burden. Anything that will help is welcome. You know, in the end, it might be that the whole coming together of all these efforts is what's going to bring it. But I think we shouldn't shut down any door. Sometimes when you have a new technology, it takes a while for acceptance. It takes a while to embed in. It takes a while for it to work and to pick up. But this is the nature of science. And so we shouldn't shut down too early. We should remember what are we trying to do, and then we should throw everything that we've got at it. So I think that the people looking at mosquitoes, all other types of intervention, mass drug treatment is now on the table. Everything we should do, because there are lives at stake.
Absolutely.
Yeah.
Yes. I'm wondering if there are any questions from those who are listening to us.
So I was very interested in your talk, but I was wondering why so many decades of efforts at a malaria vaccine have failed if people can have, natural immunity to this.
So I think there are many reasons. My own view is that we're dealing with a complex parasite, and we hadn't understood how complex it was until just about 10 to 20 years ago. Now we know how difficult it is, and so now we can study it in a more systematic way. I believe that the researchers have been trying for a long time, but they did it with limited tools. And why I'm excited about our generation and our time is that we've got massive tools now. We know the genome, we know how it makes its proteins, we know how it varies its proteins. So that's why I'm optimistic that before, people couldn't see all that. So you didn't know the beast that you were tackling. But now we know that. And that's why I feel we can make progress. Yeah.
Thank you.
Perhaps related to this question, what can we learn from immuno-oncology using immune checkpoint inhibitors or developing dual antibodies, bringing T cell, for example, into contact to the parasite? So I'm not an expert in immuno-oncology, but I think that this is an open field that we can try new strategies. My own focus has been on antibody because there was a clear experiment done a number of times where simple passive transfer of IgG did the trick. And that's what I'm chasing down. But I think that with current technology, we're open, really. We're open to any technology that we can bring to bear to solve the problem. Yeah.
Any more questions from... There's a question.
Hi, a very fascinating talk. So regarding the antibody, do you think the malaria will in the end develop some resistance if you're using the single kind of monoclonal antibody?
Definitely, that's the parasite that we deal with, but it depends what your monoclonal is targeting. If you're targeting a conserved part of the parasite and a part that's essential to the parasite, so there are some things in the parasite that it can change. There are some things that it cannot change, otherwise it doesn't survive. So I think there are different strategies. You can look for monoclonals that are functional, you know they do something, but they target a site that's important for the parasite. We can also think of cocktails of a bunch of monoclonals that we bring together that hit the parasite at different points. So I think there's a lot of discovery to be done. Yes.
And it's a tantalizing proposition to think about what Christian was saying about our ability to predict future evolution with a very different pathogen. In the case you mentioned was influenza. And thinking how we might anticipate that and indeed vary that cocktail, as you said, in potential immunization. Of course, the population dynamics will be very different, but that will be interesting. Any other questions from our audience here? Not for now. I have a really related question to what you were talking about, but now my question is about humans. Mm-hmm. So the people for your trial, this is not an easy thing to agree to.
Yes.
Participate in a trial where you're going to be infected with malaria. How difficult was it for you to find these volunteers and get them to sign consent forms and so on?
Yeah, so actually before we started, we had 2 years of consultation and engagement and discussion and backwards and forwards, getting feedback going forwards and backwards. And it was really important to do that to gain acceptability. But then we've also, so that was one thing. The second thing is in our community, we've been doing research for 30 years. And so there's already an amount of trust that the community has with us because of what we've done for many years. And so once we'd done all our engagement, this was a new study. It was the first time that really we were infecting people rather than just observing what was happening to them. Then it wasn't difficult. But you had to do a lot of legwork and groundwork before, and then getting them to explain, and then continuing to talk to them. You know, it wasn't like I explain and then I'm gone. But a continuous engagement even as the study went on, and then just providing them with some compensation because, for example, they had to stay for 21 days somewhere where we could keep an eye on them, so we had to compensate for their time, etc., etc. But in the end, it's worked very well.
That's remarkable, really. Any other questions have arisen since then? So my next question actually is, so from the way you talked about immunity, is that adults who are repeatedly exposed indeed become resistant. But of course the problem is with the children. So if we were successful in developing a vaccine, when do you think children would need to be vaccinated? Really extremely early, just after birth, or more or less at the same time when other sort of childhood vaccines are administered?
So the optimal time for logistic reasons is really when you're getting all your other childhood vaccinations. When we observe natural malaria infections, they're not so common in the first 3-6 months of life. And we think that that's actually because of maternal antibody that was transferred at delivery. But because of the logistics in Africa of getting children into clinic in a completely new schedule, I think we're all really encouraged to try and work within the window where there's already a system. They come at such and such a time and try and fit into that system. And so that's what's frustrating with the current vaccine efforts, is that they're short-lived. So if you give the vaccine to somebody at 2 months, and then the effect is gone by the time they're a year old, then that's still not good enough. So these are some of the challenges. Yeah.
Absolutely.
Is there anything that we can learn from sickle cell anemia, knowing that these people are resistant to malaria? Is there something that we can learn there?
Yes, I think that there's definitely stuff that we can learn, but we've not been able to translate that knowledge to help us to make the vaccine for malaria. And so far, the studies are conflicting. When I share the data that, passive transfer worked, that's been reproduced a number of times. So I know antibody is important. But when we look at antibody in sickle cell patients, the data is here. It's not consistent. So it might be a mechanism that's just completely different to the one that I'm chasing down. So I think, yes, we should learn something, and people are looking at it, but we've not yet been able to translate it. Yeah.
Can you also comment other aspect of a malaria control, for example, diagnosis or other like a gene drive modified mosquitoes try to prevent?
So it depends on how many hours you want to be here. So there are lots of different things. There's having treatment, good, effective treatment, having access to that treatment, because in many places in Africa, the drug is there, but people don't have access to get it. Making sure that the drugs are well stocked. Making the correct diagnosis. So in Africa, people have parasites, like I showed you in the talk, and then they might get a flu virus on top. When they come to see you in clinic, you have a look and you see the parasite, and you start treatment, but that's not actually what's making them unwell. So there's also a problem of over-diagnosis about malaria. But in general, diagnosis is improving. There's more kits that are becoming widely available. You always have to think about access. There's mass drug administration that's coming now as a preventative tool, where you just give everybody drugs that will cover them for a period of time. There's mosquito control measures. There's bed nets. There's spraying of houses to clear mosquitoes. There's clearing of larval habitats. There's gene drive. So there's lots of different angles that are being looked at for the control of malaria. So I focus on my passion, which is what I shared. But actually, there's a whole ecosystem there of different interventions possible for malaria. Yeah.
Thank you. Any more questions from the floor about anything that we've been discussing? No? Okay. I think it really is very exciting, the prospect that, such for all the wrong reasons, such an iconic disease could actually, hopefully in our lifetime, be eradicated and have that vaccine that essentially we're completely protected, and who knows, could be maybe like polio one day, and we'll be reading about it in textbooks but not actually having to live with it and fight it. Wonderful. Thank you very much, both to you, Christian, and to you, Faith. Thank you. Thank you very much.
Thank you very much.